Okay, I'm going to try to better explain what I come up with on the Kinetic splitter. I've got some dimensions there, and those are fairly robust 5/8 or 3/4 inch pins that are all the way through the center of structural tubing. I did not measure the linkage for you. It shouldn't be too tough to figure out. The spring right here just kind of helps hold it over center so that it don't bounce in and out of gear. When it does come down to engage, there's an adjustment right here that allows that set of bearings that are riding on the rack to just barely come over center to hold it engaged. If it doesn't come over center, then the handle will slap your hand hard when it comes into something. And you can see I've got a rubber bumper here so that if I have to disengage it under a heavy load, that it decelerates the handle without breaking anything. This nylon block right here is just to catch the end of the rack when it comes all the way out to help guide it back into the bearings on the engaging lever. I got a couple of just old 3/8 or 1/2 inch carriage head bolts there that kind of help guide the tail of the rack. And I'll try to give you some part numbers here, and they're kind of pricey. Their Martin pinion number is S415, and that's a 4-pitch, 1 1/8 inch bore, 4 1/4 OD, 2-inch face, 15-tooth pinion. It's $126 at Amazon right now. And the rack is a Martin number R4X4. It's 4 foot long, 2-inch wide face, same as the pinion, and it's $307 now. It comes 4 foot, but you'll end up cutting it down to, I'm not sure exactly what I cut off of it, but I'm only cutting 24-inch logs for the most part, and I thought a 23-inch stroke would be more than enough to do that. The I-beam is actually not an I-beam. It's called an H-beam, and the difference being an H-beam, this webbing is the same diameter all the way through, so it gives you a nice flat surface here for these guide wheels to roll on. This bolt is holding on to a, I don't know if you can see it under there or not, it's holding on to a fairly robust bearing that the bottom of the ram is riding on, and you can see the third bearing right there. That is actually the disengage bearing. When I let go of the handle, I need another video camera operator. When I let go of that handle, this spring, you can just barely see the spring in there. I don't know if you can see it or not, it's in there. That spring pushes down on this bearing, and it pivots at this bolt, and it allows the rack to pop up and out of gear. You do want a nice tight fit on your H-beam, so I milled slots just very slightly, but they're slots on these 6 mounting holes, 3 per side, so that I can squeeze in these 2 outer blocks to get a nice fit on the H-beam, because you don't want any play on that gear side to side. The final drive chains here I've got 2 60/8 chains, sprockets, 1 on each side. I don't have the cover off the other side. I'm not sure what the tooth count is on there, if it's labeled or not. I can give you a rough diameter. It's got an outer diameter of about 11 and 10 3/4 on the top, and about 4 inches on the bottom sprocket with just a idler. I've got 3/8 plate cut that supports all the bearings and the engagement mechanism. 2 plates exactly identical, cut identical on a mill, And you can see this little 1/4 inch hole. You may or may not see it. A little better light. There's another 1/4 inch hole right there. Those were just drilled in there so that I could index it onto the H-beam when I welded it together, so that I would make sure that my pinion shaft was perfectly square to the H-beam and left it perfectly square to the rack. I think I've gone over just about everything. This line from the actuating or engagement shaft linkage with your bearings on the back here, this needs to be pretty much directly in line, square to the pinion shaft and the rack, so that when it comes into gear, and you can adjust it right up here, that it's just slightly over center. It just takes very little pressure to disengage that by hand. There's also the same rubber bumper that I've got here. It looks like about a 2-inch solid rubber bumper. There's one in the other end there that the rack runs into, so that it doesn't mushroom out the end of the rack. And the end of the rack is also tapered off. I don't know if you're probably not going to be able to see that in the video, but it's just tapered down so that it will disengage on its own. Another pretty important part about this type of log splitter is the splitting maul itself, or blade, whatever you want to call it. I believe I ended up with about a 1-inch piece of strap here, and I probably should have gone to 3/4 and actually tapered it a little more, but it does need to be really nice and sharp to do its job. It's not indestructible. I did break a pinion in my early testing, which kind of gets expensive, so I've put a sacrificial aluminum key stock in the pinion, and just, pay attention to what you're doing splitting wood, and don't try to cut anything in there sideways or huge knots, and you're good to go. And I hope this answers most questions. The flywheel itself is off of a square baler, 240 pounds. It doesn't need to spin very fast to split a lot of wood. All the noise is coming off the go-kart type centrifugal clutch, which is a pretty important part of the setup. You need to be able to disengage the motor when the rack does stall. And the reason it's chain drive, a number 35 chain, is because they're very abundant. There's a lot of go-kart clutches on the market. It would be a lot quieter to use a belt, but the belt clutches are quite a bit more money, so that's the way I went. Alrighty, I think that should just about do it. I don't know what else to tell you other than if you don't have access to a mill and a lathe, you probably shouldn't try this at home. Thanks a lot.